The use of telescopes goes all the way back to 1608 to be exact. It was known then to be used to see things far away as if they were nearby. To give you an image, think about what pirates would put up to their eyes on ships to see the path ahead. Except now we're looking beyond the ocean into the final frontier known as space. Fast forward to today when we're putting telescopes in space. I bet Blackbeard the pirate would argue that this is nonsense. If we were to go back in time, NASA would have a lot of explaining to do.
Avast ye! NASA has recently announced that it will be launching the Compton Spectrometer and Imager, also known as COSI. This will be part of SMEX, or the Small Explorer program. This mission is set to launch in 2025 and will study the birth and death of stars, as well as how chemical elements form in the Milky Way. It will also explore the formation and decay of heavier elements that are shown through calamitous space explosions. Blow me down! If I were to bring my shipmate Blackbeard into the present day, he will probably be wondering, blimey, what is this treasure booty? What does it do?
Now let's take a deeper look. This technology is known as a Compton telescope, which is used to look at Compton scattering. This phenomenon gets its name from the gamma-ray researcher Arthur Compton. American physicist Arthur Compton found that gamma-ray photons give up a fraction of their energy to other charged particles when it interacts with them. When you track the patterns of these rays, it looks something like this.
Let's move on to a general setup.
Spectrometers have a standard optical configuration that contains a slit, collimating mirror, diffraction grating, and a camera to detect the light. The imager will then use the incoming information to sense the light and interpret what's being seen.
Now, let's talk about COSI's setup. This telescope is made to perform spectroscopy, imaging, and the polarization of gamma-ray sources out in space.
It will be able to view 25% of the sky. It will include high spectral resolution germanium detectors and will use 3D imaging. This technology will reduce the background noise by a factor of 30 to 100 units per volume.
This will be the first gamma-ray telescope that is designed to capture the annihilation of positrons.
If you don't know, positrons are the antimatter version of electrons, meaning they have the same mass and magnitude of charge, but are positive rather than negative.
To capture these galactic events, the telescope will be observing the sources that are producing gamma-ray energies that are between 0.2 and 5 million electron volts. Batten down the hatches. Moving forward, this mission will create images of the sky and allow researchers to gain a deeper understanding of star history and gamma rays, just as pirates use their telescopes to observe the ocean and the path ahead. This will enable missions to learn about different processes that shape star formation, the history of star collapses, and how positron annihilations are distributed throughout our galaxy and space itself.